We'll go through the first example in the set covering type problem. Go ahead and read through it, familiarize yourself with the problem. We decide where to put our cameras, at which locations. Each location covers a certain area of the stadium. So we want to put this information into Excel. If you open up the partial spreadsheet, I have the 12 different camera locations that we have available and the different stadium areas, 25 total. So if we just take camera location 1, for instance, that one covers stadium areas 1, 3, 4, 6, and 7. So in my Excel spreadsheet, camera location 1 covers stadium area 1, 3, 4, 6, and 7. I'm using this 1, 0 binary logic. 1 if the camera location covers the stadium area, 0 if not, or a blank. Excel will read a blank cell as a 0. And then we would move on to camera location 2. Camera location 2 covers stadium areas 4, 7, 8, and 12. And this is just data from the problem. This is a little long and tedious, so you get the idea, but go ahead and click Sheet 2, and I have it all completed for us. We'll continue with the example though. Again, what I decide is which camera location to use. I'm going to use that binary logic. If there's a 1 here, that means I'm using camera location 2. A 0 means I'm not. My constraint is that every stadium area must be covered by a camera. To find the actual number of camera locations that are covering this stadium area, I'm going to use sum product of which camera locations I'm using times whether or not they cover that stadium area. This must be greater than or equal to 1 for the minimum required. This is true for every stadium area. I'm going to slide it down, but first lock my decision variables. Double check the last one. Good. So every stadium area must be covered, but in particular, a problem states that 2 stadium areas are of particular interest to the viewers. Stadium areas 1 and 2 are the locker rooms. We want at least 2 cameras covering those locations. Also, camera location 7 is the blimp location, and that must be used. So the blimp H35 must equal 1. Our objective is to minimize the total number of cameras needed for coverage. To find the total number of cameras is just equal to a sum of my decision variables. I have 12 total. How many of them will I be using? And I want to minimize that value. Let's go to Solver. We now know which cameras to use to have a minimum total number and to fulfill all our constraints.